Okay, now this is a really big deal. Think about this now. Based on what's happened in the past, we're going to draw a line through this data and predict the future. You come to me and say, "Hi, I'm planning on studying 40 minutes. I'm going to predict your grade." That's a big deal, right? I'm going to give you your grade. This is an important deal. Okay, so how you draw this line, whatever mathematical model you come up with, is going to be what's going to be used to predict the future. All right, so if you want to give me a line, just come up and draw it real quick, what you've got. I've seen a lot of different ones out there. Go. Someone else? Well, let me draw this one. Let's see if we got another one that's kind of different. Go ahead and draw it. I saw a lot of that one out there. Somebody got something different? Yeah, come on. Supposed to be kind of straight. Okay, another one. We got something there? Very good. All a little bit different ideas here. All right, I got an idea what's going on here. I think this person, I want to touch as many of the points as possible. Okay, I see that. This one, hey, you know what? I want to kind of keep this idea going, but I need to get a little bit closer to this. And then this one's saying, well, I got to deal with you out here. Okay, so I'm going to kind of aim it a little bit more towards you, but I also got to remember these guys are here. Now, last period, 2 of the lines went directly through that point. So the question is, what's right? How do we draw a line that best fits that data? Let me give you the right answer. That's the right answer. Now, why is that right and the others were wrong? Now, here's the idea. Okay? When I make this prediction, when you give me your minute study, and I make this prediction, what's the most important thing? Do you, James, what do you want? What's really important to you when I make this prediction that I'm right about?
My score.
Your score! This is all I care about. You don't want me being wrong when I predict the score. So when somebody studies for 14 minutes, I want my line to be really close to that 32. I don't want my line. What do you guys want over here? Maybe this one's good, actually. When somebody studies 6 minutes, that's right about here, I want it to be really close to the 42. Okay? When somebody scores 126 minutes, I want the answer to be really close to the 79. I want my line to be really close to the right answers. Now, where my line misses the right answer, my line's made a little bit of a mistake, but I want to minimize those mistakes. So where on this graph, and I'll get the other lines off of here for a second. With that in mind, where on this graph are these mistakes I'm talking about? How can you see them on your graph? Where are the mistakes graphically that I'm just talking about? I don't want to be wrong here. I want to be right. But my line's not going to be perfect. So where in this picture are those mistakes? Yeah.
How far away the points are from the line?
In what way? So I got this point. How far away is from the line? What way? This way?
No, up and down.
Yes. That. Think about that point right there. I don't know what point that is. That's 42. Or 42. Maybe that's 45. Okay, so this point right here I think is 45 minutes studied and a score of 76. Now, when you give me, hey, I'm going to study 45 minutes, I want my line to predict something pretty close to that 76. My line's going to predict, I don't know, around 63 or something. That's an error. I want my line to have the smallest errors possible. I want the line that when I look at all of these has the smallest amount of red that you can have. That's the best line. That's the line that came closer to the real answers. Now take a look at some of your lines. A lot of you got really small reds here, but you know that person that went out here, how big is this red going to be? All right, you got a really big hair there, and then when I look at all the reds, I'm going to have too much red. Here's the problem. What do you think all of these reds add up to? This is back to when we all dressed up. Anybody have any idea what those reds are going to add up to? No, the length of the red. Now you guys are thinking about the day we dressed up, but what happened on standard deviation day when I added up all the deviations? What they add up to? 0. Remember when we added up all the deviations and they came out to 0? So I can't say I want the lowest average. So here's what they did. They took all of these errors, and what did we do on that day when they all added up to 0? We took all the deviations and we squared them. So here's what this line is. Find all of the mistakes, all where the line doesn't meet, square all those numbers, add them up, and that one unique line that gives you the minimum squared errors added up is your winner. That's the best line possible. Now, I'm going to ask you in a week, can you explain to me how they got this line? What they do? It's in the title. It's called the least squared regression line. So if you're ever stumped like, well, how is that the best line? It's the line where my vertical, one job. Where it's the line where my mistakes, my errors, are minimized. If I square all the errors and add them up, it's going to give me the minimum squared errors. Yeah.
So are we squaring the red, like the distance, like the red?
Yeah, the distance. So this guy was, okay, so I was off here, the real point was 76. I think this thing said 61. So I subtract those two, that's about 15. I was off by about 15 points. You'd square that, that's 225. And you keep squaring all of those, getting that big giant number, you add them all up. But I tell you what, that line is going to give you a minimum of that squared error. I draw any other line, I'm going to have these big red scores, you know, and to square them and add them up, it's not going to be as good as that line. Okay, that's the best possible line that we can have. It's called the least squared regression line. Okay, there's 3 ways. I'm going to ask you to find the equation to that line. Okay? One of them is using all these crazy formulas that are on your formula sheets. Another way, you got a nice little calculator button. In fact, you've already used it. And the other way is through mini-tab output. Okay, so let's do the crazy formula way first. Okay, there's a bunch of formulas that you can use that will get at the equation of this line. What I forgot to do is I wanted to see, let's go back one second here. One of your lines. So let me come back and draw your line up here again. I'm going to go back to finding the equation to your line.
Same exact thing.
Yeah, try as best you can. Okay, so we're going to work off of this line now. Now, what's the old equation to the line? Y is equal to mx plus b. Isn't that the equation we used back in Algebra 1 of a line where m stood for the slope and b stood for the y-intercept? Okay, we're going to just totally do everything different in statistics, just so you know. So you can forget all about that stuff. We got a whole new way to do it here. But, what can we find on the graph pretty easily? Your y-intercept. So on your graph, I don't know, what is this? 10, 20, what'd you say?
I said 30.
About 30?
Yeah. Okay,
so we know your y-intercept is 30. Now what did you do to find the slope? What'd you do?
Well, I mean, I took one of my points.
Okay.
And then I...
We actually have a point right here, don't we?
Yeah.
What is that point?
0.30.
0.30, that's a big deal. Don't forget that. We're going to explain y-intercept later. Don't forget that means 0 minute study, 30, right? Okay, now what are you going to do to find your... Did you use that fancy slope formula?
No.
Good.
I just did rise over run.
Okay, so how'd you do that on this picture?
Well, I went off of mine
Okay.
really close, and I went up 10 and over to 12, about.
So you went up 10?
Or, yeah.
Is that what you said?
Yeah, I went up 10.
So you went up 10, wherever that spot is. Is that right about there? Yeah. And then you figured out you had to go over about 12-ish?
Yeah.
Okay, everybody see what she did? So she said, okay, every 10 I go up, you're going to go 12 that way. Remember rise over run? That's what slope was. So if I was writing this equation, if that's rise over run, 10 over 12, x plus 30. Is that okay? See how she did that? For every, if I look at this a different way, for every 12 minutes studied, it looks like the score goes up 10. And we could reduce that to 5 over 6 or make that a decimal, which we're going to do today. Okay, I like that. That's a great way to do that. You all have a little bit different equations. Okay. Well, let's find the perfect equation to this line. And as I said, there's 3 different ways we can do it. All right, here we go. Statisticians have to be different. We can't do y equals mx plus b. The first thing that they do is they flip it. So the y-intercept is going to come first from this point on, and all the equations and lines you draw, and the slope is going to come second. Now, our calculator, okay, and our book use these letters. A represents, in this case, it's the number all by itself. That's the y-intercept. B used to be y-intercept now. Now B is going to be slope, just to confuse you even more. Okay? So that's how we're going to write the equation of line. If it's the absolute best fitting one, that's called y hat. That's going to be our symbol for the best fitting line. Unfortunately, our sheets, our green sheets, use different letters yet. Go find these on your green sheets. They're on your first page. These are very important formulas that you're going to be using. First of all, go find this one, the general equation of the line. It's on page 3, I believe. And notice the letters they're using to represent the y-intercept and the slope. The y-intercept, instead of A, like it is in our book and our calculator, they use B sub 0. And the slope, instead of using B, that's B sub 1. Okay? So when you see those on your formula sheets, you gotta use that. And then these are the 2 formulas that we're going to use to find the equation of that best fitting line. Okay? All right, so the first part. If you know these values, if I know the mean of the x's, do we know that if we're given these points? Yeah, we did that yesterday, right? If we know the standard deviation of the x's, do we know that? I think yesterday. The mean of the y's, the mean of the response variable, do we know that? Do we know the standard deviation of the y's? You bet. And do we know the r value? We know where to find that on our calculator. If you know these 5 things, we can get back to the equation of the line. So one of your problems tonight, you're going to be doing that. And we're going to use these 2 formulas to do it. First one, you can find your slope. You can find your slope by multiplying the correlation value times the standard deviation of the y's over standard deviation of the x's. So help me out. Let's remember from yesterday, what were the mean of the x's? They were like 33.3, is that right? What was the standard deviation of the x's? 36.5. What was the mean of the response variables? 59.7. What was the standard deviation of the response variables? I think that's right, 17.1. And I remember the R value is like 0.7227. Is that correct? All right, so let's go use this formula to calculate our slope. So we write down the formula. So if we're using our green sheets, it would be V1. If you're using the book, you can use that formula. Is equal to the correlation value times standard deviation of the y over standard deviation of the x. Okay, write down the formula first. All right, now let's plug in the numbers. The R value, 0.7227. Times the standard deviation of the y's, which was 17.1 over 36.5. Somebody throw that into your calculator, please. 0.338. Your slope was what, 5.6? So your slope was a lot steeper, wasn't it? Wasn't your line a lot steeper?
Yeah, I got
Yeah.
0.3.
But that's the correct slope. That's the slope of that line. About 3/10. All right, now, very important point. This point, the mean of the x's and the mean of the y, is always a part of the best fitting line. It's always on the line. Let me show you. So the mean of the x's is 33.3. The mean of the y's is 59.7. 33.3, 59.7, 33.3, 10, 20, 30, 40, 59.7. There it is. That's x bar, y bar. It's always going to be on the line. So remember back in Algebra 2, or Algebra 1, if you know the slope and you know a point on the line, can you use like point slope and all that stuff to get the equation? This formula is just breaking down that point slope equation of the line. So if you want the y-intercept, plug in that point with the slope and it will spit out the y-intercept for you. So let's go ahead and do that. So to calculate the y-intercept, V1 is equal to, and these are on your green sheets, right? You don't have to memorize these. Y bar minus the slope, x bar, so let's plug in those numbers. Y bar is 59.7 minus, throw in our slope, 0.338 times the mean of the x's, 33.3. This is what I want to see in your homework, right? Showing your formulas, plugging in the numbers. You want to stay in this class, you need to be working along. Okay? You're just going to get thrown out. Watch this is good from outside. What does this come out to? 48.4. So now we have our slope, and we have our y-intercept. So now, whenever you're asked to write down the equation of the least squared regression line, this is how we're going to do it. You're going to write the equation out in this form, but you're going to explain in your write-up what the explanatory and response variables are. So what do I mean by that? The equation of your line is going to be test score is equal to y-intercept 48.4 plus slope 0.338 times minutes study. Yeah.
Why can't you just write it like the y hat, like y?
Whenever we write it, we want people to look at the line, look at what you've written here, and be able to figure out what you're trying to predict and what you're plugging in. Now you're going to do some problems. Maybe they don't tell you what these things are, and they're just giving you y's and x's. If they give it to you like that, you would write y hat is equal to, you plug in the numbers. But whenever it's talking about real data and real predicting, we want our equation to, somebody could just look at our equation and say, okay, if I give you minute study, you're going to predict my test score. That's the best line that does it. So that's why we write it like that. Okay, so that's one way to calculate the equation of the least squared line. You'll have to do it tonight in your homework. Hopefully, maybe never again. I've seen some AP test questions where you do have to use the formulas to do it, but very rarely. Yeah.
On the homework, when we explain it in a sentence, is that all we write?
Yeah, you can just write it. You say the least squared regression line can be written down.
Okay.
Okay, so that's one way. Oops, that's my 80. All right, what's another way? You've already done it before. It's the same button you used yesterday. Okay, let's go back to the linear regression model. So remember, you go back into stat, over to calculate, down to 8. Now notice there's two linear regressions. This is the mx plus b way. We don't use it. Okay, we're going to use this one, which puts the y-intercept first. Okay, that's just the way it's done statistically in our book. Now remember, if the data is in L1, L2, you can just put it right there. You don't have to write anything. If it's in L3, L4, you got to put L3, comma L4. Okay, but ours is in L1, L2. Hit enter. And is that the slope and the y-intercept that we just calculated the hard way? Okay, there's your general equation. The y-intercept's first. There's the slope. The y-intercept, 48.4. And the slope, 0.33. There's R, the correlation value we learned by yesterday, and R squared we're going to talk about tomorrow, what that means. Okay, so most of the time, if you're just given a bunch of points, you're just going to use that button. You're not going to have to go use those crazy formulas. All right, the third and final way that you might be asked to go find the equation of the least squared regression line. Open up your books to page 156. All right, the graphic on the top is an example of mini-tab output. Here's what they're going to do on May 10th. They don't even want you to take the time to have to write down those numbers in your calculator and punch the button. Okay, they're going to want you to do other stuff with this data. So they'll give you a mini-tab output. You don't even have to punch the numbers into your calculator. But you've got to be able to read this mini-tab output and know where the slope and y-intercept are. All right, so I'm reading the one on the top. You might have writing in your book. That's great. If you want to put pencil stuff in there to show you where different things are, that's fine with me. The top two lines. Notice it's giving the equation of the line like we write it. Explanatory variable, in this case is gas used, whatever that means, is equal to, there's our y-intercept, 1.09, and then there's the slope, 0.189 times d-day. D-day, whatever that means, is our explanatory variable. Now here's what they're going to do on test day. They're not going to give you those two lines. You won't see those two lines. Okay, you're just going to see the junk on the bottom. And from that junk on the bottom, you've got to figure out where the y-intercept and the slope are. All right, y-intercept. Well, if you think about it, the equation of a line, the y-intercept is the number all by itself, right? That's known as a constant. So I look at constant over to coefficient. There's the y-intercept. It's written a little different, and it is rounded on top. But that 1.0892, that's the 1.09. So that's where you find the y-intercept. Now the slope, remember the slope, when we write the equation of the line, is written right next to the explanatory variable. So the next thing you see is the explanatory variable, and the coefficient that goes with the explanatory variable, that number right next to it, there's your slope. Okay, so that's what you have to identify from the mini-tab output. And then you would go write the equation of the line. All right, just point of interest. We're going to study this a lot more in a bit. You see where that S is? It's like 0.3389. What the heck is that? Here's what that is. Remember those red lines we had up here? It's kind of the average red line. Now I can't say average, right? Because they add up to 0, right? So, but if you square them, add them up, square root them, it's kind of like the standard deviation of those red lines. So that gives you an idea of how big the red lines are. If I looked at our graph, it was 15 I saw some bigger ones. I bet that number would say around 20. Right? Or 15. That's typically how far we are away from these answers, look like. Or was that your graph that was off by 15?
Probably.
Okay, so that's mini-tab output. That's the third way that you can do it. Okay, more importantly than being able to find the equation of the line, you have got to describe what those things mean in the line. I've got kind of a template here for you. Okay, so this is how I'm going to want you to write it. They're going to ask you, I think on every AP test there's ever been, they ask you this question: interpret the slope, interpret the y-intercept. So our y-intercept in this problem was what, about 48-ish? 48 point something? What does that mean in English? What does 48 mean? Think about it. For our predictor line, what does the 48 represent?
If you studied for 0 minutes, then you would get a 48.
If you don't study at all, I'm predicting you get 48. That's what that means, right? The y-intercept isn't the x0 and the y a number. So that line is saying, if you don't study at all, my prediction for you is you're going to get a 48. Now, it's a pretty bad prediction, isn't it? Don't we already know a person that studied 0 and what they got? So that's our error, right? That's a little red line. Okay, that's what our line's not going to be perfect, didn't go through every point, so our red line's off about 8. But that's what the y-intercept means. So in this particular problem, how you write up y-intercept, it's just what you said. If I study for 0 minutes, if you study for 0 minutes, we predict, the least squared regression line predicts that your score will be 48.4. Okay, slope's a little tougher. Okay, got to know what this means. Now our slope in this problem is like what, 0.338? What does that mean? Okay, now how we're going to write up slope, remember slope is rise over run. We're going to say that, okay, for each unit you go in the run. In this problem, you would say for each 1 minute study, we expect the test grade to go up, it's a positive slope, right? About 0.338 points. For each 1 minute more you study, your test grade is going to go up about 1/3 of a point. That's what slope means. And that's how we're going to write it up. Okay, so here's your template. So you'd say as minutes studied increases by 1 minute, least squared regression line predicts that your test grade will go up, okay, by 0.338 points. So if you're ever asked to interpret the y-intercept or the slope of our prediction line, this is how we're going to write it up. Okay? Threw a lot of stuff at you. I don't know if I lost some of you or not, okay? This is it. We're trying to predict the future. And if we've got a bunch of points that line up pretty good in a straight line, we've got a good R value, then we're going to fit the best line we can to those points, and we're going to predict the future with that line. Okay? This is our general form now. The y-intercept comes first. 3 different ways we can find the equation of the line. One, using all these crazy formulas. They work. You've got to know this information. Number 2, we got a nice calculator button, which you're going to use a lot. Okay? So you're not going to have to go through this process. Or number 3, I can give you a mini-tab output. You've got to be able to give me the equation of the line, but then also tell me about what those things are. Questions, comments?